Um, right, okay. So, yeah, did you see my message? I messed up again on the thing because when I looked at them, there's 3 in the middle ones. So you just did 9 and 12, is that right? Okay. Number 9, am I doing it? Yeah, right, okay. So number 9 is, how the hell am I going to draw this? I'm going to draw the square first. Right, and inside the square I have a circle. Oh yeah, thank you. And then around the square I have a bigger circle. This isn't going so well. Right, and then the trapezium is around the top like so. Right, something like that. Okay, right. A circle of circumference 12, so the small circle there in the middle, right, small circle, I know it's got a circumference of 12. So that means for the small circle, 2 pi r equals 12. Agreed? Okay, so just to get the radius of the small circle, this is the one in here in the middle. So the radius of that would be 12 divided by 2 pi, which would be 6 divided by pi. Is that right? If you want to turn it into a decimal, don't, because it says give your answer in terms of pi. Right, okay, 6 over pi. So I'll leave it as 6 over pi. Is that okay? That's, I'm dealing one step at a time. Right, okay, then it says, inscribed the outer circle touches parallel sides. Right, find the area of the trapezium. So eventually I'm going to a plus b over 2 multiplied by h, right? And I know what a is, it's 2 centimeters. I know what b is, it's 5 centimeters. Okay, so the top line, the bottom line. So I'm looking for h. So look, h is here, look at it, isn't it? H is the or the height of the trapezium. Okay, would you agree? Right, observation about the height, the perpendicular height of the trapezium is also equal to what? The diameter of the big circle. Would you agree? So the height is equal to the diameter of the big circle. So I need to get the diameter of the big circle. Okay? Okay? Right. So I can get the, wait, not let's see. The diameter of the big circle is also across here. Look at it. It's the diagonal of the square, isn't it? So the diameter of the big circle is also equal to the diagonal of the square. Would you agree? So I'm working backwards, right, to see what have I to get. So in order to get the diameter of the big circle, in order to get the height, I need the diameter of the big circle. In order to get the diameter of the big circle, I need the diagonal of the square, right? Okay? In order to get the diagonal of the square, right, I need to get the side of the square, don't I? Okay? The only thing I know is the radius of the small circle, right, but I can get the side of the square knowing that, okay? So in order to get the diagonal of the square, I need to get the side of the square, okay? So I'm just going to draw the square, okay, and this separate, okay? So I need the diagonal of the square, okay, but what I have here is, wait now till I see, what do I have here? Okay, now till I see, where am I going with this? Radius, oh, the side of the square is equal to the diameter of the small circle, would you agree? So the side of the square is equal to twice the radius, yeah? Would you agree? Right, because there's the radius across the bottom. That would be the same as up here, wouldn't it? Okay? Agreed? So I know what the radius is. So the side of the square is twice the radius. I know what the radius is. It's 2 all over 6 over pi, which would be 12 over pi. Okay? Right, I'm ignoring the little circle now in the middle. I've used all the information I need out of it. I'm going to the square now. Okay? And I'm getting near the door. I need the diagonal of the square, right? Because the diagonal of the square is equal to the diagonal of the square is equal to the diameter of the big circle, and I need that. Okay? Right, so this is 12 over pi. Okay, and this is also 12 over pi. Okay, Pythagoras' theorem will get me this diagonal. Will I just call it x for the minute? Right, so x squared is equal to 12 squared, 12 over pi squared plus 12 over pi squared. That's 288 over pi squared. So x squared is 288 over pi squared, which is, when you do that in the calculator, you get 12 root 2 all over pi. Is that okay? We all alright with that? That's just calculator work, right? Are we good? So now I'm going back to here, right? So I just established, right, okay, that the diagonal of the square is 12 root 2 over pi, right? So that's also the diameter of the big circle. Because the big circle, right, goes around here. So there's the diameter from one side to the other, right? There's the diameter, agreed? Right, okay. Now, but I know from my original diagram, right, that the diagonal or the diameter of the big circle is also the height, isn't it? Okay, so if the diagonal of the big circle is that means the perpendicular height of the trapezium is also 12 root 2 over pi. So then the area of the trapezium is a plus b over 2 times the height, a plus b over 2 multiplied by the height, so that would be 2 plus 5 over 2 multiplied by 12 root 2 over pi. That would be 6 7s are 42 root 2 all over pi. Done. Right? Area cm squared. Is that right? Good? Right? Okay. Anyone get it? You have to see a lot. There's a lot of stuff to see in there, isn't there? Right, okay. My advice is when you get loads of shapes, as in when you get this, right, okay, start in the middle, right, and see, as I did, I started with just the circle on its own, right, okay, and then I went from the circle to the square, and I went from the square to the bigger circle, and I went from the bigger circle to the trapezium, right, yes.
You know, if we got like the right answer, but we did it in different form, like the answer of it, would we get like the same points, or would they not?
It says give your answer in the form a root b over pi.
Yeah,
so technically you haven't fulfilled the brief, but you probably just lose 1 mark.
Oh, okay.
Right, okay, as in if you gave it in decimal form, is it? Yeah, you'd probably lose 1 mark, right, because you've all the workings out right, but yeah, is that right? Anything else? Any questions? Right, okay. Nobody got it? Did you get it in decimal form?
I probably got it, but in decimal form, yeah. Like I did exactly the same thing.
Right, okay, right. Okay, right, number 12, I presume I'm doing it because it's even harder than this one. Right. Okay, have you all lost the will to live, yeah? Yeah, that's okay. That happens. Right, just know there's nothing special about you, it happens every year. So, yeah, I'm trying to draw this now. Right, I'm just going to draw. Oh God, I was going so well and then I made a right mess. Oh, and it's getting worse. Okay, right, and then there's this. Okay, and the question is, 5 discs fit exactly into a rectangular frame of width 20 centimeters. Find the area of the remaining space in the frame. So I have to do the remaining space in the frame is the area of the frame, take away the area of 5 discs, yeah? Would you agree? Of 5 discs. Okay? Right, wait, and I'll show you how you get a temp marks. The area of a frame is length by width. You don't know what the length is, but length by 20 would be correct, wouldn't it? I've got marks, right? Probably got 1/3 the marks. I've almost passed the question, right? Take away the area of 5 discs, so that's 5 pi r squared. 1 disc is pi r squared, 5 pi r squared. God, I'm going really well now. I've even more marks got now. I'm nearly up to a C, right? Okay, you don't do C's. I'm nearly up to H5. I'll never get my head around that. Right, okay, right, look, they say it fits exactly, so I know mine doesn't draw exactly, right? Okay, but the width would be equal to 4 times the radius. Would you agree? So from here to here is 2 radii, and from here to here is another 2 radii. 4 radii, so you can get the radii, so that means 20 is equal to 4 radii, so you know the one radius is 5. Okay, so look, I can do 5 pi multiplied by 5 to be squared. Oh my god, I'm nearly on a H1. Right, okay, are we alright? Okay, now we have to get the, I shouldn't have rubbed that out, I don't know why I did, but now I need to get the height or the length or the height or whatever you want to call it of the wooden frame, okay? So it's all the way from here down to here, right? Would you agree? Okay, so what we need to do is, right, we need to split that up. So this is fine, this is fine, this is a problem, and this is fine, isn't it? Okay, so the bit in here is a bit dodgy. Right, okay, so what we have to do is I'm going to draw 3 circles. Just the 3 at the top, if that's okay, just for the moment. Okay, that was pretty crap. Right, okay, I drew it and then I drew it in the exact same spot. Right, okay, so I'm going to mark the centers. Okay, like a face, like a dog, isn't it? God, I'm good at art and I never know it. Right, okay, I'm going to draw in a right angle triangle. Okay, so this is straight up, right? Okay, straight across, right angle triangle, and then I'm going to join here to here. Right, okay, got this? I know that this side measures 5, don't I? Because it's a radii. What about this one? From here to here would be a radii, and from here to here would be a radii. So in that right angle triangle, what would that be? 10. Right, okay, so that would be 10. Okay, so I can find this, I'll just call it H. I won't call it H because it looks like hypotenuse. I'll call it X. Is that right? Okay, so I'm going to get the length of that side using Pythagoras' theorem. So just drawing out that right angle triangle, that's 10, that's 5, this is H. Okay, so we'll get 10 squared equals 5 squared plus H squared. Right, moving stuff around, you get H squared is equal to 75. So that means H is equal to 5 root 3. Are we good with that? Okay, everyone with me? How do I know to do this? Because I'm doing maths for 100,000 years. So like, yeah, that's how you know to do these. Right, I know you're all looking at this going, how are we supposed to know to do this? It'll come, right? It'll come, right? With practice and practice with exam questions. It will come, right? So at this present moment in time, you're understanding what's going on. If you're not understanding what's going on, then you're in trouble, right? Okay, right. As I say, these are really hard questions, really hard. Okay, so back to my diagram up here. Okay, so this is a radii, would you agree? So that would be 5, right? This is the height I just got here, right? So this is the height I just got there, which is, what did I say it was? 5 root 3. Then I have the mirror image down here, so from here down to there is also 5 root 3. And from here to the end is the radius. Okay, so that whole length would be 5, I'll do it 5 plus 5 plus 5 root 3 plus 5 root 3. Okay, tidying that up, and you can turn it into a decimal if that suits you. That's 10 plus 10 root 3. Okay, so if all that surd stuff scares you, turn it into a decimal by all means. Okay, is that right? So I want the area of the frame back over and back to here. So the area of the frame is the length, which is 10 plus 10 root 3, multiplied by the width, which is 20, take away 5 discs, which is 5, multiplied by pi, multiplied by 5 to be squared, into the calculator, press equals, and whatever you find the area in the frame, they don't say correct how many places the decimals. Okay, so right, I'll just do this in my head and I'll get 153.71 cm squared. Is that right? I didn't do it in my head, I read it off the answer. Yeah, I was joking. Yeah, I'm good, but I'm not that good. Right, is that okay? Right, are we okay? Yeah, I know you've lost the will to live. It's okay, it's fine. Right, it'll come back around June 12 months. June 30th, 12 months. Right, okay?
You know how all of those circles, yeah, no, because I just assumed like that they were all the same, like the radii. So how are we meant to know?
They are all the same.
Oh no, I know, but I didn't mean the radii, like the length. I thought that the length would be just like three
Yeah.
circles, so like I thought it would be 30. So
Yeah,
how are we
but
meant
it's
to
not,
know it's not
yeah,
like that?
in order for them to be 3 circles, the circles would have to be stacked on top of each other,
Yeah.
okay?
Yeah, 'cause
Then
there's
it would be
6
3
there,
circles,
yeah.
right? But because it's here, then it's over here, and then it's back over here, it's not 3 circles, okay? Because from here to here is not a is not a diameter, right? Is that okay? Right? Yes.
Can you just go over again how you got that 5 root 3?
Yeah, okay. Right, okay, so do you know how I drew that right angle triangle? Right, okay. You know the way this one from here to here measures 5, and from here to here measures 5, so that side of the triangle measures 10. Right? Pythagoras' theorem, the hypotenuse squared, which is 10 squared, equals 5 squared plus h squared. Okay? So that means h squared equals 100 minus 25. When you square 10, you get 100. When you square 5, you get 25. So that means h squared is equal to 75. And you get the square root of 75 on your calculator, and it'll give you 5 root 3. Okay? You can turn it to a decimal if it makes you happy. Right? Because I turned it to a decimal in the end. Okay? But, right, I just kept it as 5 root 3.
And then how did you get the up there that 5 plus 5?
Okay, right, okay, so what I'll do is, can I draw out the, I'll draw the diagram again, because I've that one all scribbled on. Okay, so you have your 5 discs, 1, 2, 3, 4, 5. Right, the triangle I drew was here. Okay, and I figured out that that one was 5 root 3. Yeah? Is that okay? There's a mirror image of that triangle down here. Look, if I did it up this way, it's the same triangle, so this side is also 5 root 3. Is that okay? And then from here to the top is a radii, or radius, so that's 5. And from here to the bottom is also radius, because it's the equivalent to this over here. So that would also be 5. And then you add 5 plus 5 root 3 plus 5 root 3 plus 5. Is that right? Okay, so from here to here is 5, because it's the equivalent of a radii over there. Is that right?
Yeah.
Okay. And have another look at it tonight. Know what you know now. Right? That's the best thing to do with these sums, because it's all very fine looking up at me and seeing what I did. But if you have another go at it tonight, right, and you know, close the book, close the notes, start again, right, okay, and see, can you figure it out like that? Because looking at it done, like this is just a load of maths on a page. Do you know what I mean? You need to figure it out in your head how it was done. Is that alright? Okay, right. Then we went on to 3-dimensional objects, and I asked you to get the volume of the ones on page 177 and the surface area. Does anyone need me to do any bit of number 1 on page 177? It must have been a breath of fresh air after that number 12. Yeah? It was all okay? Right, okay. Right, okay, can I move on so? Right, I was on 3-dimensional shapes and I did a cylinder, did I? I just did a rectangular block yesterday. And did I do a cylinder? Yeah. Okay, so now I'm on to a cone. Cone, girls, was not on your junior cert course. Okay, so cone is new to you. It used to be on the junior cert course, but you did the new junior cert course, didn't you? Were you supposed to do the new junior cert or the old junior cert? The old junior cert, it was on your course, so it's all not new at all. Right? Okay, so it was on your course. They took it off the other one, the next one. Okay? Right? Girls, the formulas for these are all in your log tables. Okay? So you don't need to remember the formulas, you just need to remember how to use them. Okay? So the formula for a cone, for the volume of a cone, is 1/3 multiplied by pi, multiplied by r squared, multiplied by h. Now h is the perpendicular height. So this is r, and the perpendicular height, girls, is a straight up height. Okay? So it's from the centre of the circle at the bottom right up to the tip of the cone. And you all know cone, a cornetto. You may notice I turn all my shapes into food. Yeah. Okay, so we had a cylinder with Pringles, right? Okay, a prism. Did I do a prism yet? No, that's a Toblerone. Did I do that yesterday? No. Yeah, I did a prism yesterday. So a Toblerone. Yeah. Okay, a cone is a cornetto, right? Okay, we'll come on now in a bit to some Maltesers and stuff. Okay, so right, curved surface area. Right, girls, curved surface area is if you open your cone and you flatten it out, this is what it'll look like. So you'll have this weird looking shape and a circle. Okay? So the curved surface area is this bit. So this is the curved surface area, CSA. It's just this bit. Now what you need to get for this, girls, is the, you need to get the, this is called length. Okay, it's called the slant height of the cone. Right, so it's actually up here, right? That's the slant height of the cone. You need that for the curved surface area, and the curved surface area is in the log tables. It's pi r l, right? If I have the perpendicular height and I have the radius, how do I get the L? Looking at that diagram there, what's in there? Right angle triangle. So you use Pythagoras' theorem, right? Okay. So if you look, you can get a right angle triangle in there, which is the perpendicular height, the radius, and then you can get the slant height. So they never give you all three. They'll give you 2 out of the 3, and you have to use Pythagoras' theorem to get the other one. Is that okay? Are we all right? Right? Okay. The total surface area, girls, is not in the log tables. You have to use your head. It's the curved surface area, which is this bit, right? Plus this bit. What is this bit? This is a circle. What's the formula for the volume of, or area of a circle? Pi r squared. So you have to use that one and add on the circle. Okay? So as I say, that's not in the log tables. The curved surface area is, but you have to recognise to add on the extra circle. Okay? Are we good with that? Okay. Can I go? Yeah. Okay. Next one is a sphere, which is a Malteser. Right? I could say a football, but listen, I'm on the food thing, so it's a Malteser. Right? Or if you're very posh, it's a Lindor. Right? Okay? Right? So yeah, that doesn't look like a sphere at all. That looks very weird. Okay? Volume, girls, for a sphere in the log tables again, 4/3 pi r cubed. Okay, so all you need for a sphere is a radius. Sorry, move it down. Sorry, I need to do that.
Was the code a third?
Yeah, 1/3 pi r squared h. Yeah. Okay, just remember with the sphere, girls, the radius can go in any direction, so it can be that way. It can be that way. Remember, the radius can go in any direction, okay? Because sometimes people don't spot it, right? Okay, it's more with the hemisphere than with the actual sphere. But anyway, total surface area in the log tables. So if you were to get your football and flatten it out, not possible, right? Physically not possible. But if you were, the area of it would be 4 pi r squared in the log tables. Please note. Right, okay, as we're going through these, right, volumes always have a cubed in it, areas always have a squared, right, okay, please note as you're going through, if you look at all the formulas, right, volume always had 3 lengths multiplied by each other, radius multiplied by radius multiplied by radius. If I just look back here for a minute, this one is radius multiplied by radius multiplied by height, so it's 3 lengths multiplied together to get you a volume, right. To get to an area, it's 2 lengths multiplied by each other. So radius by radius. Okay, length by width. Right, radius by height, something like that. That will get you an area. Right, so if you multiply 2 lengths by each other, you'll get an area. 3 lengths multiplied by each other will get you a volume. When you see one of the questions I'm going to give you in a while, you'll understand why I'm saying this. Okay, is that alright? Hemisphere. Hemisphere not in the log tables, girls, okay? So a hemisphere is not in the tables. So it's a sphere cut in half, okay? So it's a sphere cut in half. Volume, if the volume is 4/3 pi r squared or pi r cubed, what's the volume of a hemisphere? 2/3 pi r cubed. Because half of 4/3 is 2/3. Is that alright? Now, total surface area, right, what would you think it might be? Half of that, so that would be 2 pi r squared, but guess what, it's not, because that will only give you the surface area of the curvy bit down here. But when you have the sphere, you actually exposed an extra circle, didn't you, up top? Right? So the total surface area is actually half the sphere, right, which is 2 pi r squared, plus the extra circle you've produced. Okay, so it's like 2 pi r squared and 1 pi r squared makes 3 pi r squared. Okay, so it's not half because you've actually exposed an extra circle right at the top. If you have an orange, there's an extra circle up at the top that you couldn't see before, but now you can see. Right, are we good? Right, so the formula is 3 pi r squared. Is that alright? And you tell me I've done prism, yeah? Okay, right. So what you're going to do now is you're going to do page 177 to 178. Right, you're going to do question 2. Now it says to put them in order. Don't bother putting them in order. Just get the volume and the surface area of each shape. And when you've that done, we'll move on to the next bit. And I'll stick it up now, right? So you're doing that now. It's not for homework, it's for now. And when it's done, we're moving on. Okay? Yeah, so I'm putting it up now. Hello. Who's, yeah, she beat you to it, but go on, the two of you can go together. Don't be chatting. Fifth year maths. Okay. Right, the first few shapes are gone up. There's another 5 shapes on the next page. Okay. Question 2. There's 8 parts in it to get the volume of each, a volume and surface area of each shape. Okay, volume and surface area of each shape, and I put up the answers so you know you're right. They put them in order, don't worry about putting them in order, but just when you're looking for the answers you have to find the right order. It was number 2. Right, I put up the answers. And hurry on, because I want to move on. And a couple of girls said to me yesterday about making a phone call. Would you put your name and the phone number you want me to ring on a piece of paper and hand it to me before the end of class? That'd be great. Okay, if you want a phone call instead of a Teams call, and if not, you're getting a Teams call. And if I can't read your writing, you're getting a Teams call, which is what happened in my third years. I couldn't read her writing. I must have rang 4 people. Okay. Centimetre squared. So centimetre squared, metre squared, it's area. So, yeah. Daddy, you give me a number as well, aren't you? Good girl. Thank you. Are we all okay? Yeah, you can. Yeah, if it doesn't specify, can you give your answer in pi? Yes, 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 you can. But I think they want you to compare all of these, so let's go to 2 place of decimals. Okay, I'm telling you 2 place of decimals, right? Thank you. We're finished at 10 to, aren't we? I just remembered that. Sorry?
How do you get the curved surface area of the sphere? Like not the full surface area.
Which one?
Curved E, so I can like have that and then
E. Yeah, you get a,
half it, and you don't get it out of
that would be, it would be the surface area, is it?
Yeah.
It's a whole sphere divided by 4, because it's only a quarter of a sphere, is it?
Yeah.
Okay.
There's another like,
And there's an extra, there's a half a circle and a half a circle, which makes a full circle, isn't there?
yeah.
So it's a quarter of a sphere and a full circle. Does that make sense?
Yeah.
Yeah. Are we good? Anyone need any help with any of them?
For part E is what is the diameter or the radius?
The radius. Because, you know, the way there's a half a circle here and there's a half a circle here. Would you agree? So if you flattened them, it would make a full circle. So that means the 12 is just a radius. Okay? If you're stuck on any of them, give me a shout.
would Nicola Ryan come to reception at the bell, please? Nicola Ryan. Also, a sum of money was found in the grounds yesterday, can be claimed at reception, and a white watch was found today. Thank you.
Okay.
Probably a